Which are am I able to hear? Hello, am I audible?
Yes, yes, you are audible.
Oh, okay, thank you.
You can share your screen.
Oh, people are ready?
Yeah, I have made already the live. So I will just start and I will take the session to you.
Oh, okay, just a second. Okay, uh, fine. Let's start.
Yeah, no problem. You can take your time. I just inform participants to wait for 5 minutes.
Oh, okay, fine then. So you will tell when to start, right?
Yeah, yeah. I will start the session and I will take give it to you. I will
Okay,
transfer.
fine. Oh, fine, sir. Okay, then. Thank you.
Once if you share the screen, I will start.
Which screen is visible, right?
Yeah, your screen is visible. Shall I start?
Yeah. Good.
Yeah. So myself, Dr. Abid Naimuddin, working as Associate Professor in the Department of Electrical and Electronics Engineering and the convener of this FDP. It gives me a great pleasure to welcome all the participants to this Day 5 session of the 1 week international level faculty development program on Introduction to Artificial Intelligence, which is going to be held during 9th to 14th October 2023, organized by the Department of Electrical and Electronics Engineering in association with NI Labu Academy of GPREC, Department of Emerging Technologies in Computer Science, and Department of Electronics and Communication Engineering. Now, as we are continuing the same resource persons, Mr. MK Pawan Kumar. So I request MK Pawan Kumar to take over the session.
Sure. Thanks, Abid sir. So let's start the session. So let us start. Okay, I'm not sharing anything right now. Don't worry. Um, so uh, so what we'll do is basically what we studied yesterday is we'll do a small recap, and then I'll slowly introduce you to the cloud, and then I'll slowly connect how ML and cloud will get connected to each other, and then we'll develop some code very similar to yesterday. I'll not go too much into the theory, and then we'll do some hands-on, and then I'll show you in live how we can actually expose this to the external world, and I'll explain you some of the architectures and all. Okay, so yesterday what we studied is basically predominantly there are two different groups or categories of solving machine learning problems. One by supervised approach and the other one is the unsupervised approach. So when coming or dealing with supervised approach, so you have data and then there are labels associated to the data, and then you divide that particular data into two training set and then test set. And over the training set you will train your models, and with the help of test set you will actually get your you will test your model to get some accuracy measures. And based on that accuracy measures you will decide whether to go with the model or you need to retrain or fine tune that particular model. So that's what we have seen. So we have taken a data set in real. I think like we have taken the sleep disorder data set, and then we saw a very important aspect which is called data visualization or data pre-processing part of it. So, or we call it as data wrangling as well. So uh, what we did is we saw how the data is spread of the data we call it as, with the different curves. And then we were doing like um, multivariable data visualization. So we were comparing different attributes with the target attribute. Example like how your age is actually giving or depended on the target variable, that is your sleep disorder. And very similar to that we saw how gender is impacting, how number of steps or the physical work is impacting. So we saw different spreads of the data. And then finally we constructed a ml pipeline by using some standard libraries of sklearn. And we used one important thing which is like scalars. How do you scale the data? At the same time we used encoders as well, because we learned yesterday machine learning algorithms cannot run on a categorical data, so you have to change that to a numerical nominal form. So uh, we changed every categorical data into the numerical formats using the encoders. And we saw like there are two different encoders. One is one hot encoder, and then the other one is a label encoder. Yeah, we predominantly use label encoders to change the entire dataset, and then we saw how the dataset looks once after converting or encoding it. And then that particular encoded dataset we started passing into the pipeline, and ultimately we constructed a model. And that is where like we have stopped. And now today we will pick it up from there. But just before picking up from that particular point, I just wanted to introduce with you with cloud, what exactly this cloud is. Okay, so now there are a lot of concepts basically. Okay, but okay, so cloud computing is simple actually. Okay, so it's someone else's computer, that's what I can just in a single sentence I can tell you. Okay, it is also a computer but running somewhere else, but which has got remote access. Okay, so there are multiple cloud providers, example Azure, AWS, and GCP, predominant players of the cloud. And there are other players also, but these are like major market players. So what they provide ample number of services, and we have to take the advantage of those services, which will make our life easier. Why? The reason for that is you cannot maintain the whole infrastructure from your end. So if at all you want to expose the model or some other things from your end, so you have to create servers, you have to have the firewall protection for the servers, because once you start exposing a server to a public internet, there will be definitely an attacker which comes into picture, and then he will start bombarding your servers with some kind of a malicious activity. So you need to safeguard. So there should be a firewall to protect it. And you should also, once you are telling that okay I am providing a service, then you should promise the customers who actually uses your service with the availability time. That means uh, in 24 hours of time, you cannot say my service will be only available for 6 hours and other 6 hours is a power cut. No, right? So it should be available like 24 cross 7. Example like your Hotstar, Amazon Prime, and all those things, right? So whenever you just go in, they start working, that's it. So that means their availability is almost like 99.999999, almost till I can say 7 to 8 nines. Okay, so that much availability that they are providing. Very similarly, you have to provide. So availability is a bigger problem. So if you consider different aspects like this, how do you handle all those? So instead of you writing as a programmer, you guys writing a code and concentrating on the business logics, like what is need to be done from a logic point of view, you unnecessarily waste time on all these things, maintenance part of this. Okay, so most of the time goes there. And so what if suppose network goes down, internet is gone, your logic is working fine, your servers are fine, everything is fine, but your internet gone down. So that time also your services will not get exposed to the public internet again. So unnecessary maintenance will come into picture when you once you start taking the ownership of hosting it or hosting the services on yourself. When I say services, it could be some kind of logic exposing to the public internet. So in this case, you can always assume whenever I tell a service, you can actually translate it to a machine learning algorithm. So you are exposing one algorithm to the end customer. So in that way you just assume, but there are n number of services that are by default provided by all these cloud providers. Okay, so yeah, I just these are all definitions like on demand self services, heterogeneous access. So you can access it from anywhere, any network, all those things will come into picture. Measured services, resource pooling. So and what is the benefit you will get out of cost? Because unnecessary maintenance that I told, right, that obviously incur to some kind of a cost. Okay, so that cost you will eliminate. At the same time, your speeds will be more. Your it can be globally scalable, so you can actually deploy a service in multiple regions. I can deploy it in USA, I can deploy into EU means European region, and I can deploy it in India, that is Middle East and Asia. So I can deploy basically where my customer resides. In that particular zone, if I can deploy, the accessing speed or speed would be little higher. Reason being is, it is local to that particular geography. Example, you if you deploy a service in India and all your customers are in USA and they start using it, obviously you can expect some kind of delay in getting that application up and running in at their end. Reason being is all your data has to travel entirely from USA to India, and then it will touch your service, and then again the response all over the way, it has to travel from India to USA again. So of course it's not like you are traveling in an aeroplane and it takes 20 hours, but definitely it should take some kind of a time. It will be like 2 seconds, 3 seconds, something. But till that time, what happens is your web page will say loading, 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 and that is like irritating, right? So that's like global scaling. So if you scale it across the geographies, that latency can be brought down. Productivity is one more thing. Performance, as I said, like that performance boost can be higher. Reliability, you can rely, trust it. Okay, because they give almost a benchmarking of 99.59 of availability and all those things. So that is where reliability comes into picture. Security is another aspect that I said, right? So there is always a threat from attackers. So all these cloud providers, they keep on updating their security policies and all. So which you will have the top notch security always available at your foot. Whenever you want to use it, you just use it. So all these things you are not taking care of, it is like by defaultly offered by the cloud. Okay, so now coming to the cloud again, there are three different things like public, private, and hybrid. Public clouds basically anything that is hosted and available for any third party, like they are public clouds. Private cloud is basically inside a cloud provider we can actually create a one specific private workspace kind of a thing, where it can be only accessed by your organization or specific company sector or a zone. Then what will happen is that will become as a private cloud, so no one else can actually access it. Hybrid is basically, it's the word itself tells, right, it is a combination of public and private. I can use both the combinations of these two, then it will become a hybrid cloud. And then there are three different structures of how we can use the cloud. We can use infrastructure as a service, so we can uh, take the cloud only for the infrastructure part and then manage every other than that by yourself. Example, like you want to create a virtual machine, so you can take that any cloud provider and ask to spin up a virtual machine. So virtual machines are like infrastructure for you. Otherwise, you want to store something, like if example, like you take your Google. So Google provides something called Google Photos, right? And then your Gmail. So both has got storage associated with it. So if you are asking for some kind of a storage inside cloud, that becomes a infrastructure. So you can ask only infrastructure. Okay, I need only these infrastructure to be maintained in my cloud. Yes, cloud offers that particular facility, nothing else apart from that. Again, it also comes up with some other kind of offering, which is called PaaS, which is called platform as a service. Okay, let's say basically you can actually take one complete platform, maybe cloud, how I can say, your Gmail, right? Your Gmail or Google Docs is the best example. Okay, so those are like a platform as a service. And or else, like I can say, your I don't know if you all know this or not, but yeah, going forward I'll touch base a little bit on that as well, like your Kubernetes, or Red Hat OpenShift, which are called like what I can say, container orchestration platforms. So that can be bought into the cloud, and then cloud can actually host that, and then they can give you as it as service. So that is called a platform as a service. One software platform can be installed directly onto the cloud base. That is what it is. Software as a service, yes, any software you can put, and then you can offer it as a service to the downstream applications or end customer. Example, your Gmail comes there, it's a software as a service. And then your Google Docs. Okay, any in fact, if you check like that, like there are a lot of software as services that can be hosted onto the cloud, and then you can start take leverage the advantage of what exactly to be deployed, and how it has to be deployed, and whom it has to be given the access. All these things you can actually govern by some kind of a configurations. So these are very very important, like how many different types of offerings a cloud gives is basically infrastructure as code, platform as a service, and the software as a service. These are all normal things, and this is the cloud computation stack, which is like little important. So you are having some servers, and then you have infrastructure on top of that. And then in this infrastructure there are three major sectors. One is compute, where the compute means your processors, the network attached to the infrastructure, and the storage that is being attached to this infrastructure. Comes then with platforms. The platform has some kind of software components and software services, and then comes your application on top of the platform, which has user interface or some kind of a machine interface. And ultimately comes the client can be a human or a downstream application, a third party application, which can access the application hosted onto the cloud. Okay, and now the comes with the scaling. Why should I go for cloud? This is the major use of the cloud, first of all. Okay, so what if suppose in traditional normal days, once we started software engineering way back in 2000s. That time how it used to be there is like everyone used to maintain their own hosting, as I said in the starting of this lecture, right? So that time what you used to do is like suddenly there is a huge traffic. These days you might know this Big Billion Day and Great Indian Amazon sale or something like that, right? All these sales are there. So how much traffic a server receives that particular time, even though you have a need or not, you just go in and browse, no, all these websites. So that is like a huge number of requests that are coming at that time. How do you scale? How do you handle all these customers with minimal latency? That is the basic thrive or the desire which has advent in building this cloud computing. Okay, so this has got something called vertical scaling and horizontal scaling, where I can actually scale my services as that to balance or to help the incoming requests. I can actually do this. uh, And now, as I said, right, these are like things like IaaS, PaaS, and SaaS. So this is the stack. So first comes the infrastructure as a service, then comes the platform as a service, then software as a service. So out of this, you can access anything. So you can ask for infrastructure, you can ask for a PaaS, or you can ask for a SaaS, and finally your cloud clients will directly interact with that. So with this, what I'll do is I'll not go too much deep, as I told, right? This is enough for you as a cloud thing. But now we will see how we can build one small API. Okay. And what we will try to do is we will basically, hold a second. Okay, we will slowly create a container. I'll tell you while creating itself what container is, how it will run, all those things I will tell you. So with that, what we'll do is we'll start. Okay, I'm bringing my IDE. Just a second. Okay, so on the desktop, I'll say maybe. I'll say some different API I'll create. Okay. Once you understand what is an API, then I will construct the same API for serving our ML model also. Okay. First, you need to understand what is API and how it works and all. Okay. So now what we'll do is basically I'll say some uh, because I used to love coffee, but these days I stopped it. So I'll create a project called I love coffee. Okay. And okay. So okay, now I selected my interpreter and then on desktop and my project name. Okay, go ahead, create. Fine. Okay, so this is good. So now I have my project. Now we will see like what exactly is this API. Okay, just don't worry. So I'm creating a new okay, my directory which is called src, which is called source. Okay, inside this source I'll write a Python file which is called main. Okay, and inside this main, what we will do is basically we'll create, we'll import something. We are going to use a framework called Fast API. Okay, there are multiple frameworks to create the API functionalities. One being the Django, the other being the Flask, and the recent one being the Fast API. Flask and Fast API are the micro frameworks for creating the API structure, but Django is a full-fledged framework. So for our purposes, we are not going too deep into the API framework. So we need a micro framework. Micro framework is more, I mean, like it is more sufficient. Okay. So how we have to do it? Like from Fast API, import Fast API. This is the first statement. And okay, so the second one is I'm writing some app is equals to I'm initializing my Fast API. Okay, and maybe like I'll write one definition which says like help. This is like a dummy method for me, which will return a Python dictionary. So basically you should be little well versed with the Python basics. Okay, this is a Python method and which is writing me up returning me a Python dictionary with a key called health and response called okay. And I am annotating or decorating this with app dot get. So there are multiple okay verbs, we call them as verbs in creating APIs. So we call them as HTTP verbs. Okay, those are get to fetch the data. So that means whenever you are requesting the data, we use get. So whenever you try to save some data into the database, we call it as post. Okay, whenever you try to delete no, before that I come to update. So whenever you want to update some data inside database, we call it as put. Okay, and then whenever you want to delete some data from our database, we call it delete. Okay, and there are many other HTTP verbs basically. um, just a second. Okay, so okay, there are many other verbs, but most predominantly these verbs are used. The reason being is we most of the time we deal with CRUD operations. So that means create, read, update, and delete, which we call it as CRUD. Okay, so these CRUD operations mostly deal with that. So if you are doing some kind of a create, nothing but post, read is nothing but get, update, which is nothing but put, delete is always delete. Okay, so we deal CRUD operations with these HTTP verbs or HTTPS secure. When we call HTTPS, it is secure. So HTTP verbs, we do this. So now whatever my method is doing here, it is just returning, which is nothing but like when I query this method, it returns this. That means it is not doing any operation on the database, nor neither it is saving, updating or deleting. It is just like reading and giving me back. So I just decorated. That's the reason I decorated with get. Now I'll say this is the path. So this is done now. Reformat. Okay, now this is done. How to bootstrap or run it basically. So I'll just go to configurations here. Okay, and add it. I should have my fast API, and I'll select my source main.py, and I think I should be done. Detect automatically application name. Okay, apply, just say run. We'll see. Now if you see this, it ran something called uvcon, which is called the server. Okay, and the application is available on this particular URL. Okay, now I'll show you some magics. Okay, let me pull out some tool which is called Insomnia. Okay, and here I'll okay. I'll say maybe I'll create one project which is GPR workshop. Okay, so in this I'll create a new collection, maybe like APIs demo. Okay, APIs demo, and now we will say HTTP request. And now see this HTTP localhost. It was running on 8080/health. And now if you see it here, get. See, whatever I told, I have it here. Get, post, put, patch, delete. So that's what I told, right? There are many others, but I'm not telling you. So most of the time we deal with get, post, put, patch we will not delete, but delete we may delete. But I don't know if time permits, I'll explain everything. But get I'm doing now. Send. Okay, maybe cannot connect to server. Why? It was running on 8000. I said 8080. Okay, fine. Send. Now see this. This is giving me a response back saying that health is okay. Okay, we queried health API. So the health of the server is okay. That's what it meant by. So now slowly we'll little deep dive. So what we will do is def. I'll say okay. Get coffee list. Okay. So now what we'll do here. Maybe I'll say COF coffees is equals to one empty array. That is a list in Python. Okay. So what we'll do it here is uh, written coffee. Okay, and we will say @app, and then decorate it with get, and then say /coffee. Okay, so now just restart. Okay, even before that, like it says unnamed, right? Like edit the configuration, and let's make this as coffee API. Okay, now run it. Go to the tool. Instead of health, let's say, okay, let's save it. Okay, this one you just rename. There is something called rename, which is called health. Okay, then add one more request, which is like http localhost colon 8000 slash coffee send. So you are getting empty array. Okay, so now what shall we do? Now let's copy this method. Okay, we'll say instead of get, now we'll say post. Okay, we'll say coffee, save coffee instead of get coffee. Okay, and then what we'll say, we'll pass some payload. That means like some body. Okay, and then that body gets saved into this coffee basically. Okay, maybe like I'll say I'll send some array of strings. So for which what I'll do is I'll create one Python file, separate Python file, which is called coffee payload. Okay, okay, okay. Here what I'll do is okay, instead of that, first of all, let me import from pydantic import base model. So we are creating some payload, we call it as model. Okay, from typings import, oh, I'm sorry, import, I think I'm saying as a list. Why is it? Okay, okay, list. So now say class payload, I say payload, and which will extend base model. This is how you inherit from a base class inside Python, right? So and then we go as data. The actual data where it passes is called, I'm naming that particular value as data, and the type of the data is a list. So if you know some Java and all, we always I'm sorry, none. Okay, so we always have data types, right? Now Python also come up with the data types. You can associate a data type, and it actually verifies that in compile time only, and it will tell you whether you are doing right or wrong, and that is available from your Python 3.10 and 3.11. Okay, previous to that you don't have this kind of facility. Okay, now you go to main, and here what we will do is I'll say normal payload. So this is of type uh, okay, maybe I have to import first. Yeah, from coffee payload import payload. So this is of type payload. Okay, and now I can say coffee dot append payload dot data. Okay, so that's it. So what we'll do is now let's rerun and then check what exactly happened. Then you will get a lot of clarity. What happened? No module named coffee payload. We have it, right? Okay, what is it telling? Maybe I'll say src dot coffee payload. Okay, let me run and check. Perfect. Okay, fine. So I have to give the relative path. I don't know why it is not taking src as my base root. Okay, let's debug that later point of time, but this is working. So what I'll do is now let's create one more request, which says http localhost colon 8000 slash coffee, but this time it is post, not get. Okay, and then your body is of type JSON. Okay, inside this JSON I'll pass an array. I say mocha is a kind of a coffee, and then what else we have? Espresso. I think I assume that these two are correct, and then we have latte as one type of coffee. These are three different. I think like cappuccino is also one, but now if you just send it, okay, and now you just go to your get coffee and then send the request here. Okay, of course it is not coming in. Input should be a valid dictionary or object to extract the fields. Okay, fine, got it. So okay, let me do that. Okay, there is an error, so I have to actually tie up to the data. That's what I wrote it, right? Data is a kind of array. This array, I'll push it to the data. That's what it is telling. It should be a kind of dictionary. Okay, so beautify JSON. So yeah, so I sent it. So now go to your coffee and then extract it. So now see this. Okay, so what happened? So it inserted all these array into my array items. Okay, so now you just start pushing the data. So all your data would be, you can actually test your APIs are working. Now you don't even know, go into the code base. You just push it from here, you read it from this API, you push it from this API and you read it from this API. Now you can actually code the delete and put also in the very similar way. I can actually delete one particular word or a coffee. Basically I delete one coffee from my menu item. Assume that you are running a coffee store, and then you want to remove one of the coffee from your list of available coffees. Reason being is that is out of stock for now. So you can actually do that. Out of this array, you have to delete one particular item that you have sent, that you may be sending it as a payload. So this is the kind of API. This is what we were talking about. So API is this. Okay, now what we will do is we will give the similar kind of API for a machine learning algorithm now. So what it does is we will say something kind of a slash predict. Okay, and this predict, what it does is it actually loads the model, and then it takes this payload, and to that loaded model it will pass this payload, and it will predict the answer, and then finally returns a response. So entire all this operation is done in the background, but a user sees this. You will pass something here, you send, it will say okay whether it is true or false here. That's it. So you don't know what is exactly happening in the background, but what is exactly happening in the background is this. Who does this? It is we. As a programmers, we create all this infrastructure, these APIs, the business logic, how it has to execute, what it has to do, everything. And now you expose it, and ultimately a customer or a consumer will do it, and finally he's satisfied, because he don't know, he doesn't need what exactly to be done, but he ultimately cares about the output. Okay, hope you got what exactly is an API. Very basic understanding. Okay, now what we will do is slowly we will convert this into a Docker. No, I'll tell you what Docker is. Now I am running it on my Mac machine. If I export the same code onto a Windows, it will not run. It might not run. Okay, maybe because of operating system problem, or it could be some kind of an environmental or a software problem, because my software in Mac would be little different than a software inside a Windows, because your run times are different. Okay, it's a platform dependency, we call it as. So how do you make your software platform independent? Okay, so how do you do it as an independent? Is basically you create a one container is a atomic entity where your code as well as operating system both resides in that particular loop, and you can port this container to any of the platforms like Windows, Mac, anywhere you push it, it will start working as is. So by that, what you are doing, you are eliminating the underlying host system platform dependency or operating system dependency. Okay, so suppose you write this is well known to you guys, right? I think, like, if at all you know, if you are learning Java versus C, this is the first statements that we learn. C once developed on a Windows cannot be run on the second Windows also, or it is developed on a Linux machine, you cannot run the same C program on a Unix machine or a Linux machine. I'm sorry, Windows machine. Okay, But whereas Java, when you developed on one particular machine, can be ported onto the some other platform. When I say machine, it is about, I'm talking about a platform, underlying operating system. Okay, so you developed it on one operating system, but you can port it onto the some other operating system and it will run. Very similar to that, if you want to do this kind of functionality where you want to bring some kind of a platform independency into the picture, that is where Docker comes into picture. That is one aspect of Docker, but there are multiple aspects, like you can scale and all. I told, while telling the cloud, I told two different concepts: horizontal scaling and vertical scaling, right? That is only possible using this Docker now. That is the whole point. Like, I introduced the slide, I introduced the API, now I am introducing to the Docker such that you can correlate these concepts. Okay, now how to write that? Okay, just simple, we will see it. I'll write something called here, one file which is called requirements.txt. This is basically managing of the dependencies. So I'll say fast API and uvcon, which is the server. So which versions I want to install, this is the one, and uvcon also 1.2.3. This is like a false version because my id tells what is exactly the recent 0.23.2, so I just modify that 0.23.2. Okay, what? Okay, fine. What is about fast API? It says 0.1.3.2. Okay, 0103.2. So this is the beauty of my id. So that's the whole point, I use this. Okay, it keeps on guiding me. Oh, fine, requirements is done. Now you create one more file which is called docker file. The name itself is docker file. Okay, it, and you cannot change it. If you change it there, then you need to do extra some configurations and all. Otherwise you just leave it as is, you don't bother about it, then everything is fine. Okay, so now what I'll do is, I'll write something from, okay, python 3 hyphen, maybe I'll go with, these are all Linux images, guys. Okay, okay, these are all Linux images. So maybe I'll choose latest Linux version. Okay, and so I'll say, okay, what to do here? Okay, okay, fine, Tiga. So maybe what I'll do is, instead of my source directory, I'll just pull out these two files here. Okay, refactor it, and then I'll just delete my source here. So now what we'll do is, we'll create the Docker file and then we'll see how it goes. So because one step down, I don't know how, if at all we encounter issue, then it'll again, there will be a lot of time waste to debug that issue and then fix it. So I just bought it everything to my root directory. Okay, fine. Now let me say run a command called mkdir, which is like make directory slash code, and then we'll say we will assign this work dir slash code. That means it says, okay, you create this code directory inside this operating system, and then make that as my root directory. Work directory is basically the root directory, and then I say copy. Okay, copy, and then we'll say this requirement.txt. Maybe I'll copy, I don't type it. Okay, copy, and cancel this. Okay, copy, then paste dot, and then I'll say run pip install hyphen r requirement.txt. So whatever the dependencies that we kept in this, they will be installed inside that Linux environment. Because if you see this, I installed something called fast API even way before like this session start, like so many days back. That's the whole point, I was able to import it. So anything, any module that you are trying, basically you have to install it. So I am installing it in my Linux operating system. This is basically an OS image. Okay, so and then finally we say copy dot space dot. That means the first dot represents the current directory, that is I love coffee here, and the second dot represents your work directory. So that means you are telling copy all the files from here to my work directory. Okay, and then the ultimate command is cmd, and then we say run the server, which is uvcon. That is what I shown you, right? In the log also you'll find it, uvcon is running. So that means this server is running. So you say run this uvcon. Okay, and the application is main colon app. That means from the main module run the app. So main module, under the main module you have something called app as a fast API. Okay, so that one, and then we'll say host hyphen host is your where exactly you want to run. That is 0.0.0.0. If you have a networking knowledge, the 0.0.0.0 is called the loopback IP address. That means it points to the same host. And ultimately we will say hyphen port. Port is equals to maybe I'll say same thing, 8080. Yeah, 8000 or 8000, something like this. Okay, what we will do is I'll stop this. Okay, this is the Docker. So now I have my Docker installed. Okay, if you follow my cursor, if you see here there is an icon. Okay, so this is my Docker which is running. So now I'll show you some commands. Okay, Docker images. So these are all my Docker images that are there here. Maybe a lot of things got installed. Okay, let it be. Now I'll say Docker build -t, which is like tag. Maybe I'll say coffee API space dot. That means in the current directory build. So now if you see this, it is installing this Linux machine. I'm sorry, Linux image. It is building, it is downloading everything. It is installing our requirements. Done. Now I can show you something. Docker images. Now if you go up, you see my coffee API, it got built. Okay, now I'll say Docker container run publish the port. Our port is basically 8000, so I'll map 8000 colon 8000 and hyphen name, that is coffee API space. Okay, one name is the name of the container, the other name is the name of the image. Okay, from this particular image you are trying to create one container. Okay, so if I run it, see this, it is running. And now just open your this one and send this get. So it should work very similar. You don't feel any difference actually. So now you just post it and come back to the get and do this, everything is working. But where is it working? Now let me show you this. This is my Docker desktop. Okay, Amunda platform, I'll just stop that. So now see this coffee API. So it is running in my Docker basically. Now all the logs are coming here. If you see this, okay, so it is running in my Docker, but not on my desktop. If you see my editor or the IDE, we are actually not running. Everything is stopped. Okay, now where is that running? It is running in my Docker. This coffee API, if you see, this is running in state. If you see it here running from past 54 seconds, and the usage of CPU is 51%. Now that is like 24% because no request is coming. So let us give the request and see the CPU strike or a spike, anything. Okay, okay, again we said get. Now if you see this 0.5% of the CPU, that got almost like 0.25% of the CPU is getting spiked for every request. After some time where there is no utilization, the CPU is given back to the operating system again for further processing. So this is the whole reason the compute is very important. What if suppose there is a huge load coming into picture? So this CPU will go on spiking. So you cannot maintain, right? You cannot tell I will bring one more processor and put it on my motherboard and I'll create one more server. No, right? So these all can be done in cloud very fast within some clicks, like 2-3 clicks. You can create one virtual machine and then you can expose it immediately. So this is the whole point. This is how you will test a real-time application. Now what we will do is, now since you understood what is Dockerization, so how I converted a program into a container and then hosted onto the Docker, now we will see how we can create an API for a machine learning algo. Okay, maybe I'll not create a Docker and then put it onto a Docker, or neither I will code directly, but I have some code already. Since I have coded it from scratch in front of you, so I have very similar code for one of the machine learning algo that I'll show you guys. Okay. Okay, so this comes here. Okay, so yesterday we were doing this sleep disorder, right? So maybe after these sessions, what I'll do is I'll share all these notebooks, these PPTs, everything to you. Maybe like I'll give it to Abed sir, and then he can share if at all whoever needs them. But what it is, I have another thing also. This problem statement also we were actually discussing yesterday, which is like employee retention, for which yesterday night I was doing some analysis again. So there I created one model, one pickling, saving of the model. So we call the saving of the model as a pickling in machine learning. Okay, pickle basically what it does is it actually saves the model in a binary format. Okay, now if you see it here, you see it here, k neighbors classifier dot pkl is the extension of pickle. Okay, so now what I did, I saved this model, the object model, into this model file. Model file is k neighbors classifier dot pickle inside a write binary format. Now what we can do is I'll show my app API. So we are loading the model. So for loading the model, you need to do something like this. Okay, I'll close this. You need it, don't need it, you'll confuse. So pickle dot load will load the model. So I'm giving the entire full absolute path, like k neighbors dot pickle dot read binary. Since you have written it already while you are constructing your model, now I am reading it back. So I use a read binary, so it comes into the model. Now what we are doing is we are basically using something called a predict, and I send some payload. That payload will be passed into this model and say finally predict, and then we will say whether employee will leave the company or employee will not leave the company. That is the major thing. Okay, let's run it. Okay, it is running. Okay, so it is almost the same thing. Okay, same kind of a behavior. And let us open our insomnia, and let us go to one's personal projects where I have these three. Okay, okay, maybe here itself we will do it now. Okay, let's create a new request again. This request we will rename it to coffee again. Okay, it is like post coffee and get coffee. Okay, and we will say new http method. We'll say http localhost. Did it run? No such file or directory. Why? Users pawn manta pawn workshop key neighbors classifier workshop. I don't know. Maybe like let us take this copy path or reference, absolute path. Okay. Okay. So let's do stop rerun. Okay. It is 8,000. What happened? Ran out of input. Pickle dot load. Okay. Maybe like I have to stop my Docker just a second. So I'll stop because it is also running on the same port. Okay. Now ran out of input, end of file. Okay, I think there is some issue in my pickle actually. Okay, let's do one thing. So I'll rerun whole file so that it will create the pickle file. Okay, now coming to here, I'll rerun the model. I'm rerunning the API. Let us see. Yeah, I think there is an issue in the pickle, so I reran my entire machine learning notebook and it recreated this pickle. That is how the issue is gone. So what about my payload? Payload is basically a data is a list. Okay, fine. Okay, so what we will do is we'll create open this localhost colon 8000 slash predict, I think predict, and the this is post, and the body is JSON is JavaScript object notation in which we have data, and that data is an array. Okay, I have a sample data already here, so I'll take this, copy, so this one, and we'll send it. Okay, so now he says, will he leave the company? He said no, with this particular data he is not leaving the company. So maybe like we'll change this parameter, some parameter, maybe to 4, and we'll see. Yeah, will he leave the company? Yes. So maybe as a, you can develop an application now, and then expose this API where it will be used by some other developers or some other third party, where they will start passing you different data that they have, and your model will start predicting based on the algorithm or based on the problem statement. If you design it for a biological use case, then it will start predicting the biological use case based on the data. If you have designed it for some HR, this kind of application, it will do that. If you do it something else, it will start predicting. But this is how you can combine an API with a machine learning model. So this becomes a pack now. This if you just leave at machine learning, then that is of no use actually. So you have to develop an API which will load that model, which will expose that model to the external world, and it will take some data, and then it will start predicting on dynamically in real time. That makes it more useful. And now what if suppose you can convert this into a Docker image and put it into the Docker container as we did previously? That is even more higher, and then it will become more advanced as well. So if you can create this as a Docker container, that is like ultimate level, and that Docker can be ported anywhere, and then you can export it to someone else and ask them to run on your own machine also. That is fine. With this, so we will end up today's session. So just a recap of today's session. So we started with the yesterday's review a little bit, then we saw little cloud computation part, what exactly and what are the different services they offer, and then we created one API from scratch, which is I Love Coffee. And then now you understood what is an API, HTTP verbs, and how to utilize those APIs with a tool called Insomnia. And there is other tool which is also called Postman. So you can use either of the tools to test the APIs. And now what we did, very similar concept of API we applied in yesterday's machine learning problem, and then we exposed the machine learning algorithm as an API, and then we pumped some data and it started predicting out. So this is we call end to end machine learning life cycle. And we also saw Dockerization, how you can convert a particular code base into a Docker containers and port it. Hope, I think like you got it. Today we'll stop this session here, and we will leave the next 5 to 10 minutes or 15 minutes as for questions. And tomorrow we'll continue with a new topic which is also a part of machine learning. That is a totally different dimension of a machine learning, but that also come under machine learning part. Over to Abid sir.
Yes. Thank you very much, Pawan sir. So almost as today's was a hands-on question, most of the people they are giving Avanija Reddy. She is saying in for very informative session, sir. Uh, Hiranmoy Medhi, enlightening session, sir. Thank you so much. Renuka, she is asking, is there a possibility of getting two outputs, Y1 and Y2? in a regression problem?
In a regression problem, you don't have any two outputs, right? Because if at all you are dealing with multivariable regression, like you have number of attributes, but your prediction would be one. Example, let's take the environmental science as one of your case study, where you have a lot of attributes like what is today's rainfall, what is today's temperature at three different timings, like morning, afternoon, and evening. And just a second. And then and then you have humidity levels measured, some different attributes like 10 or 15 different attributes. And finally you will tell whether I have a rain or not today. So even though you have n number of attributes, but ending you will only have one value to predict. You cannot predict two values. No, that is not possible. So whenever you say y1 and y2, that is your target variables. You cannot have two target variables.
Yes. I hope it is answered. Uh, yes. As the time is already 6:30, so Mr. Pawan Kumar, sir, today almost everyone they are giving the compliment. Informative session, nice session, and one suggestion they are giving that can you use magnifier while explaining at least once, so that the we can view the screen visible clearly.
100%. That maybe like tomorrow I'll try to do that.
In some yes, yes,
Yeah. So, but as I say, all these code will be available in my GitHub repository. I'll give you that link where you
okay,
can directly download the code and you can start
yes,
playing
yes,
along with the data sets you will have there. At the same time, I'll even forward my presentations and all these things to Abid sir.
yes, yes, I will share, sir, don't
Yes,
worry.
and then you can get it from him. So all these things we can do. Okay, I'll give everything to you guys, whatever we have studied and learned,
Yes,
and that will actually help you guys. Okay, don't worry. If you are not seeing it, also don't worry. You will have the working code available in GitHub. You can download, run it at your end. It will work.
yes, 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 let us close as time is 6:32. So dear participants, on behalf of G. Pullareddy Engineering College, I thank everyone for joining this session. So feedback link is already posted in the YouTube live chat box. So please fill the feedback that will be considered for attendance. And on behalf of Triple E Department and G. Pullareddy Engineering College, and I once again very much thankful to today's resource person, Mr. K. Pawan Kumar sir. Thank you, sir, for spending your valuable time with us, that too for 3 days. Thank you very much. Here is the end of session. Tomorrow, shall we continue with same time, sir, Pawan sir?
How is that working for you guys? So if at all we can connect at a little morning session also, it is fine, because tomorrow is Saturday for me. I can come at around 10 o'clock,
Okay.
and then we can take 1 hour session, like 10 to 11, or maybe like 11:30, 1.5 hour session. That is fine. But tomorrow is like very, very interesting session. You will find it very good actually, because we are dealing with something called time series analysis, a part
Yes.
of machine learning. So now you, with these 3 days, I think like you will have a very good enjoyed sessions, like regression, classification, APIs, cloud, dockerization, and then time series. So you will have a very good energy that you can go home, work on all these things.
Yes, yes. So it's purely based upon your convenience, sir. If you, we will discuss and we will finalize by the end of today, and I will share the same to the participants.
Maybe we can come at 10 o'clock, sir. 10 to 11. That is fine.
10 to 11, it is
Yeah.
okay.
Yeah. Nice. No problem.
Okay. Then it is fine. No? We will go with, as tomorrow is also a cricket match is there.
Oh, okay. Yeah, correct. I forgot only. Okay,
uh,
okay.
and
So
more.
with your, okay, I don't even watch it, but yes, to the convenience of students, and then
Yeah,
as per our tomorrow's match. By the way, whose match is that?
India versus Pakistan.
Oh my God. Okay, fine then. Okay, TK.
And
So
yeah, most of the participants will be,
yeah, they
in,
are willing to watch and then
yes,
enjoy
yes,
that match in. I
yes,
think it is
yes,
in the evenings, right? Okay, go ahead. Tomorrow we'll take a class at morning, such that it won't even. When is that starting? I think it is at 2 o'clock. I guess, if I'm not wrong.
a match is 2 o'clock.
Yeah, so then we'll start at 10 to 11, where no one will get an interruption. So you listen to the subject, go ahead, watch the match, refresh, and then in the late night you start practicing.
Yes, yes,
Fine.
yes. Then I will intimate all the participants.
Yes, yes.
There is will be a change in schedule.
Yes.
Okay,
Okay. Okay.
right. Thank you very much, sir.
Thank you,
Thank you.
sir. Thank
Thank
you,
you.
guys. Have a nice
Thank you.
day. Bye bye.
Right. Bye.